Hello, good afternoon, good evening, and thank you all for joining us tonight. I'm Dr. Amir Gorji, Director of Clinical Affairs with TRI Implants. I have been with TRI for a little over 6 months now. Prior to this, I was with Sprint Ray for 3 years as the head of the workflow and the material department. I work closely with Chris Luter, our president. Some of you might know him. We work, in a lot of aspects and projects. I'm sure that you can figure out how I ended up here now working with him again. As a director of clinical affairs with TRI, apart from dealing with, fine-tuning clinical digital workflows related to TRI implant, I also onboard all new customers on the entire United States on the TRI implant system. And since I'm an expert in the 3D printing and digital dentistry, I also onboard and help a lot of our customers in getting into 3D printing and start a deeper dive into digital dentistry journey. I'll be kicking off our meeting tonight. We have Dr. Ryan Dunlop here with us, who will present us the Eliminating Abutments from Full Arch to Single Tooth Implants webinar. Dr. Dunlop attended the Harvard School of Dental Medicine and spent 2 years after that at Sinai Medical Center, Bronx, studying dental implants. His practice in Fresno, California, Better Life Dentistry, is one of the largest dental implant practices in Central California. He's the CEO, founder of Full Arch Masters, the most advanced full arch training program in the industry. He teaches digital workflow, advanced surgical protocol, and he has an in-house laboratory. He has been training dentists from all over the world, teaching them the full arch dentistry and digital dentistry. We are very much delighted to have him here as one of our top KOLs with the TRI abutmentless implant system. Thank you, Dr. Dunlop, for being a part of tonight's webinar. Before I ask Dr. Dunlop to take over, I would like to provide a brief introduction to TRI implant system for those of you who are not very familiar with it. So the TRI implant system, the journey started all in Europe. You might have not heard about it. This is not a new company. The TRI implant system company started more than a decade ago. They have been, it's based in Switzerland, everything manufactured, designed, and produced in Switzerland. We all focus on, all the key points like performance, simplicity, and of course, the matrix system has been all developed around the digital workflow. The matrix system has been around for about 4 years now. In US, a little under 2 years, I want to say. But obviously, that's the abutmentless digital dentistry that we are looking for. But why do we want abutment or abutmentless? The abutment today, obviously, what they help us with is correcting our implant angulation. They take the mechanical load, they pass the mechanical load to the implant. It's easy on delivery because of having that kind of internal hex or internal connection, basically. And obviously, because it raises the implant platform, it makes it easier for the hygiene. It helps us to have a good hygiene in there. But at the same time, there are complications with the abutment. I call abutment as a middleman here because that's where it connects the restoration to the implant. And we always want to get away from the middleman. Anyway, the complications with the abutments, as we know, we do have to use cement if at all we're using a tie-base. And with cement, there's always a problems like debonding, or if there's any excess cement, even leading to implant failures. With abutments, we always have to fight against which one do I need to choose. There are so many varieties in the height, anywhere from 0.8, depending on the implant system, 0.8 millimeter going all the way to 6.5. And also the angulations, 17, 30, 45, and now recently I heard 60 degrees. So all of that is going to, increase the error. I'm sure that, at some point you have seen these kind of mistakes or errors happening. And we have to do a lot of work again just to get that kind of correction done. While, having that kind of headache, the whole, keeping the inventory, the cost of it, and all of that also is going to be added to the whole, picture, which is going to be a bigger headache. We also know because of the abutments, the height that abutment is going to take, obviously we need to do some bone reduction. Once that is, away, that bone reduction is going to be removed or much reduced. The other issue we see a lot with the abutments is because most of the times we're dealing with screws such as desk screw, Rosen screw, and those kind of screws. We see a lot of screw loosening, we see a lot of breakage, and that's again because the limitation we have in the size of the screws that we're doing. And added inventory, added cost, already talked about it. Those are the things that they come with the abutment. So the moment we can take away the middleman, we obviously get rid of all these issues as well. Clinically, what we see here when it comes to the abutments, I'm trying to see. Okay, yeah, there you go. Clinically, you might have experienced when you're doing a full arch, the first thing the patient does trying to look at the the full denture from up and down and just to see how the aesthetics is. And oftentimes they just, lift the lip and see how it looks like. And there are times that your abutment is being exposed, or, the way that you want it doesn't look the way that you like it. Or in the middle picture, as you can see, the timepieces are debonded. So you have to go through the pain again and do a lot of work to get that thing fixed up. But what abutment free implant dentistry can bring me? So obviously, this groundbreaking technology that enables us to now deliver to the patients with the implants with no abutment is really the game changer. Eliminating the cost of whether it's a zirconia or a titanium abutment. We all know how much costly that's going to be. Reducing the components, that the traditional implants can take, and basically the amount of the inventory and energy that our team needs to put into it. Not having the screw loosening, not having the micro movement that because of that the screw loosening can happen. Eliminating all of that comes with removing the abutment from the equation. Obviously, we're going to reduce the surgical and the restorative steps a lot. Again, we're going to talk about it, how those are going to impact. Your time is your most valuable thing here. The more you spend your time less on the chair side or with the patient, obviously, the more you're saving on your time and on your life. So at the end of the day, we also want to make sure that it's a fast workflow. We can get from the root to the tooth as fast as possible and as quickly as possible. So not only we're saving time, but also we're going to have a very happy patient. Here I'm going to just play this video real quick for you. All right, I guess it's working. Technology. I'm not sure if you have the sound behind it. There's a music going on, not much, but this is actually showing the interface. This is our multi-level implant line. Basically, we have two bone level and the multi-level. We also call it the tissue level. It has got this pink anodized color on top of it with a big platform, which is at 20 degrees, and it allows us to, it allows the restoration to rest on it very beautifully and very nicely fit on this and rest on this. As you can see, it looks like a trilobe, but it's not a trilobe connection. The implant is going to just sit on there. There's going to be a little extension or a little wall to give you that internal lock when you're dealing with the single implant, but that's going to be even removed in the multiple. As the video shows here, the tensile strength, stress and the compressive stress, these are going to be all passed through the screw down to the implant. So all these forces are going to be taken away from the restoration to the implant through that bolt screw, which is like 2.8 millimeter bolt screw. So I was mentioning that, we are in a digital era, and digital dentistry is something that we want to focus on. TRI, or the matrix, to be more specific, is all, developed for the digital dentistry. Today, up until today, most, I want to say all of the implant systems, what we have is we have the implant system, and we have to make the digital dentistry or digital workflow work with our implant system. But the matrix has been developed on the digital platform. So, and based on that, because we are a digital company, we also offer, all the integrated apps coming with it. Scan and Smile, digital healing colors. Digital healing colors is huge. I'm not sure why other companies are not actually picking this up to be able to provide different, healing colors based on what's required at that particular site, or even not making it white to look better. We have the Scan Bridge as the next app, the guided surgery, tooth in a box, which I'll be talking about it. Design for the lab design, the lab milling, in case you have any in-house, technicians for you who designs for you, or if you have a milling center in your office, we can definitely help you to, get running your lab inside. And of course, we have our Academy, which is another one of our apps that we're offering on our digital platform. Scan and Smile in 1 hour. This is really being practiced today. You place your implant for your singles, you place your implants, you do your scanning, you book a designer, or if you have a designer in-house, you send it to the design, get the design back, and then you print it. Obviously, you want to have a printer in-house, and then you deliver it. Everything happens in 1 hour. Depending on your workflow, it can take another 10 extra minutes or 15 extra minutes, but most of the times it's about an hour, which is happening today. So this is a real root to tooth solution that we're talking about. Here we are having a very satisfied patient, obviously, because the patient is walking out with a temporary rather than going with an S6 or a flipper, which is very time consuming for the patient, and it's not going to be the same result at the end of the day. It can create a different and a new revenue generation, because now it's totally a different kind of marketing that you want to have. It's going to be fast. It's not going to take much of your chair time. And overall, it's going to happen in a very short period of time. Patient walking out happily and successfully. This is one of Dr. Dunlop's case. I'm sorry to take some of your storm here, Dr. Dunlop. Beautiful case. We are so proud of this particular case. I'm sure that he's going to cover it, in detail, but this is at the time that he was delivering the final. You can see how beautifully the emerging profile is healed. Obviously, it comes from a masterwork, but obviously the design also helps a lot here. With the temporary design that we had for this particular case, the healing was so perfectly done. We didn't have to do any kind of redesign. We took the same, temp, and then milled out of it and dropped it in like a charm without any problem. We're all talking about, how we can have a better patient experience. And obviously, when we're talking about Scan and Smile in 1 hour, and the result we saw that Dr. Dunlop got on that particular case, or on many other cases, it all helps to have an enhanced patient experience. The way that we help to have a good soft tissue development, the way that we are trying to eliminate the flipper and the Essex, and the quick, turnaround time, recovery, and everything. At the end of the day, it's all about the patient experience and the patient satisfaction, which can help us here. Digital healing color as another one of the applications that we offer. Obviously, this is gonna change your life. Being a fully digital, solution, we do offer the digital healing colors in form of these kind of STL files. So these come in different size, different shapes for different teeth and different sites. And then you use one of these. Obviously, it has the emerging profile preformed, and this helps your emerging profile in case of your singles to form, and get a beautiful emerging profile, again, like the one that you saw. And then when it comes to the final, the designer takes the same kind of healing color, this digital healing color, and build on top of the emerging profile or base of this So you're going to have the very, very predictable and expected results of how the final is going to sit or is going to look like when the final comes, which is totally a game changer. Here's another example of how this posterior case is shown using one of those digital colors from that library. By the way, that library, in case you don't have a printer, we can always send it to you. And you can see the result. Now, the designer obviously, and this is from, obviously just a pre-final step. Obviously, the designer is going to take the same STL file of the digital alien color, is going to use the base, which fits beautifully in this emerging profile, in this on this implant and the emerging profile, and then build on top of that, and basically deliver the final. I'm going to show you here regarding the, what kind of angulations we can have on our implants and how we can get the, access opening to the screw channel corrected. So we can have up to 50 degrees plus minus on the implants. And because we have an angulated screw channel, the ASC ability, which corrects the angulation up to 30 degrees. So when these, access openings fall in aesthetic zone, we can always get it corrected with that angulated screw channel. Obviously, full arch dentistry is something that many of us are looking into it or are already doing it, right? So in case you're doing you using photogrammetry, which is great, but we do have the scan bridge, which is the next solution to the photogrammetry. There are a lot of offices using the scan bridge. There is this Prime, I think Star, if I'm not making a mistake, in Bulgaria. It's this clinic that they do like 42,000 implants out of one clinic. All they do is full arches day and night, and it's a very big clinic, and all they use is matrix system with scan bridge in order to get everything fast and quick, and they always get the passive fit. So the way the scan bridge obviously works is, if you've heard of OptiSplane, the same concept, but then it's much faster, much easier. And of course, there's no cost to it because you can always print these blue pieces and it costs you pennies. Or if you don't have a printer, we can always send them to you. If you're doing the photogrammetry, we are present in all the photogrammetries out there in the market today: ICAM, Micron Mapper, Tuple, and pick every one of those. We are available, and you can use it. Again, with the eliminating the abutment, making it easy workflow. You don't have to worry about any Rosen screw, power ball. You get the divergence of 50 degrees and get it corrected with the angulated screw channel if you need to. All of that help at the end of the day to have a very fast workflow, very efficient workflow, and be able to deliver the smile when the first in the same surgical session to your patient. Here is the live scanning of the scan with the scan bridge. For those of you who are doing a full arch, you must have experienced when you're doing your tissue scan with your scan bodies. I'm sure there are a lot of good scanners out there, but at the end of the day, a lot of time, they miss, and they basically, you have to go back and forth, back and forth, back and forth. And when you have your scan bridge like this, as you can see, it may miss once or twice, but the quality is phenomenal, and it's totally different. At the same time, it's not going to miss like any other thing that you see. So there are a lot of questions regarding, okay, we are all putting the pressure on that screw, and how tough is that screw? I'm sorry that you can't have the sound here. We are trying to explain what's going on. So we have this zirconia crown, and we have the matrix implant with the 2.8 bolt screw that we have, and the crown is being fixed with a 35 Newton on the implant, and then that's being fixed on at an angle. Actually, I think it's like 30-degree angle. Yeah, at a 30-degree angle, and then we're going to add weight on it just to see how much it can take. As you might have known, the maximum pressure or the force that a human can basically, create is about 80 kg. So we go up to the 80 kg to show that it can withstand the maximum that a human can actually can apply to it. And again, remember, this is at an angle. But then we're going to add more and see how much we can go. Funny, one of the people from the audience there, he shouted, "Let's do 170," and then we went up to 177, which actually shows how much of pressure this implant and the screw together can take it. Another thing that it shows here, and I want to show it to you, which is really, really interesting. You can see that the marking on that little, metal bit, which was, in between the weights and the implant, you can see the marking that the zirconia created the marking because of all the weight happening on top of it, but nothing happened to the implant or to the screw. So we have also done, other testings, a lot of testings we have done on this matter, just to make sure everything works. We have done a billion cycle. Yes, that's a billion cycle with a B, just to see that whether, it works or it doesn't, it breaks or it doesn't, and it didn't. And there was no fracture, there was no micro fractures, no nothing. And a lot of studies are done, independently in different universities or labs. As we claim that we are a root to tooth solution, so we promise to provide everything. We also provide a kind of lab service, I want to say, so that you have the tooth solution as well. So if at all you need a design, let's say you have a surgery and you need a design at the time of surgery so that you can get that design back, print it, and deliver it to your patient, we do offer a full arch design, which gets back to you in 60 minutes for just $250. You can book the designer in advance, and the same goes for single tooth. That is only $20, and you receive the design within 20 minutes. And that's how you can actually do the scan and smile in 1 hour. We also offer, full arch zirconia. If at all you have an in-house lab or you want to do the characterization yourself, but you want somebody else mills it for you, we can give it to you milled and sintered for just $600. Our aesthetic full arch, fully finished, is just $9.99. And then we have a very high aesthetic one, which we call it Hollywood Smile, and that's just $1,500, fully finished, given to you. We also have service for the single crowns. Again, milled and sintered only in case you want to do the characterization and finish in-house. That's about $60. But then we have 3 tiers in crown. We have the aesthetic one, which is 110, the high aesthetic one, which is 160, and then there is a custom aesthetic, which is the super highest. It's going to be all layered and everything at $180. And everything is going to be, somewhere between 3 to a week, you're going to receive your zirconia. So the question that we have been getting is, okay, it's very good that we are eliminating the abutment. We love that we're eliminating the abutment, but then I also love to, get paid for it. And I used to charge, get reimbursed by insurance. What do I do now? Now, the good news is that you can still charge a patient. And this has been vetted by, Heartland. And this can definitely be used in a way that, because the way that we have reverse engineering the index on the implant, that is considered as your custom abutment. And for the same reason, you can use the, custom abutment code D605057 and actually get reimbursed on that. Just before I close down, I just wanted to provide a couple of promotions we have today. So in order to get a starter pack, we have a starter pack of 25 implants that, is going to cover all your final screws, the bolt screws, obviously. There's going to be a surgical kit coming with it. And you're also going to get your scan bodies, titanium scan bodies, which you can, basically autoclave and use as many times as you want. The value is over $13,000, but you're going to get for only $66,875. And the other, bundle that we have is the sprint tray bundle. For those of you who are in the market, to get a sprint rate printer, with 100 implant, you're gonna get the sprint rate printer for free. You're also gonna get a surgical guide for free. And also, I would be there for sure to basically onboard you on the 3D printing and the whole digital workflow, so you don't have to worry about it. Believe me, sprint rate today charges you somewhere around 3,000 for just that onboarding of the 3D printing. So it's really going to be great. On top of these, obviously, we are going to add another special here. Thank you again, Dr. Dunlop, for the specials you're helping us here. You can have either one free zirconia arch, or you can have free final zirconia implant crown. And it doesn't matter whether which implant system you have. Let's say you're using another implant system here today, and you want to go for a final for that patient before you switch to TRI. You can use this towards that basically case. This is going to be valid for all of those, those of you that sign up with one of the bundles by end of next week, Friday. That's October 11th, that we receive the order. Definitely you're gonna get this one. You can also get the 12 months 0% financing for those bundles that I showed you. Well, thank you again, and here is my contact in case you need to reach out and have any questions. I would be more than happy to help, and see you in the near future. Dr. Dunlop, thank you again for being with us tonight. I pass it to you, and I'm going to stop sharing my screen.
Great. I think you guys can see my screen now.
Yes.
Okay, great. Okay. Well, thank you, Amir. That was very informative. I always like seeing all this good stuff from you guys. Very, very innovative and forward-thinking company. That's one of the reasons why I'm so attracted to this implant and so attracted to this technology. Is you guys are definitely ahead of the game when it comes to digital workflow. So let me go through some basics here. Why this is all so interesting, why we care about TRI dental implants and why we care about dental implants in general is the market for dental implantology is exploding across the country and across the globe. You don't have to go very far to be bombarded by dental implant advertising these days. Just open up Facebook or watch TV or, go on any of the social media platforms and you'll be hit with dental implant advertising in basically every city in America now. The dental implant market in 2015 in the US was valued at around $1.8 billion. That's a pretty big market already. But by 2026, that's expected to grow at least 23% a year. So we're experiencing double-digit growth in the implant sector and have been for at least 10 years. The global market for dental implants is expected to reach 13 billion by 2023. Obviously, we're past that. It's somewhere in the range of 14 billion worldwide now in 2024. And I believe it's supposed to pass 15 billion by the end of 2025. So we are on an upward trajectory for full arch dental implants, single tooth dental implants, overdentures, anything that incorporates dental implantology. So as we know, there's close to 40 million people in the US alone who have lost a single arch of teeth. So that's about 20% of adults over the age of 65 have at least one denture or two dentures in their mouth. So there's a huge aging population of people who need this dental implant therapy, and it's very successful. This is great work if it's done well and it's done properly under the right supervision of a qualified dentist. This can be a 2% failure rate or a 98% success rate after 10 years. There's very few phases of dentistry where we can promise that. Usually we tell people it's a 50-50 or it's a 70% or an 80% or maybe, gosh, even a 90% success rate after 10 years. But dental implants can show a great success rate after 10 years when done correctly. So let's talk a little bit about what the old story has been up until a few years ago. Dental implantology was frustrating, it was challenging, it was inaccurate, it was sloppy, and most of it had to do with these things. We had older implant systems that had sloppy internal hex connections. There was a lot of micro movement of componentry. As Amir alluded to, these abutments were sitting in space and trying to transfer load to the implant, but they weren't really because they were wobbling and the screw connections were weak. We relied on panoramic x-rays and periapical x-rays for our treatment planning. We would do ugly, nasty things like denture pickups, chair side to give people teeth. We would use obnoxious impression materials to try and get accurate representations of the mouth, but it never really worked. We do repeated verifications till we were blue in the face, and then our prosthetics still wouldn't fit very well. We would try things in wax. Teeth would be melting and moving and shifting around. I used to plan cases and send Polaroid photographs to the lab. I'd do the old Polaroid and it would come out, and I'd send that with the case. We were using prefabricated connections like tie bases and prefabricated abutments because we couldn't mill with any accuracy. We couldn't print with any accuracy, so we had to rely on prefabricated parts to attach our implants. This is a slide I like to show from maybe 5 or 6 years ago. I was at a lecture in Arizona, and this guy was talking about this great deal through this implant company that he had where, you know, for a limited time only, you could spend about $8,000 to $11,000 per arch for the implants and the guides and the abutments and the cylinders and the verification jigs and the wax rims and the try-ins and the prototypes and the final restoration. He was telling people with pride that paying this kind of money per arch restoration was a good deal. In my world, that's not a good deal. You know, some of these places that are advertising now are charging about $11,000 or $12,000 for an arch of implants. So these days have to be gone. We have to be able to provide things more efficiently, more cost effectively, and more predictably. So the new story that TRI is kind of trailblazing is the ability to take patients like these and give final restoration in as little as 3 visits. You can do all this in a week if you want. You can finish your cases off super fast. You don't necessarily have to try things in anymore because you're harnessing the power of digital technology and you're 3D printing very accurately, you're milling very accurately, and you're avoiding a lot of the pitfalls associated with these multi-unit and prefabricated abutments. So now we can choose whatever materials we want, whether, like I said, we want to print, we want to mill, we want to do combo. We're using technology for accurate planning, and we're getting predictable results. We're able to mill and print direct to the implant, as you'll see in a few cases here. This leads to less overhead. There's less inventory, less parts. When you're using a system like TRI, you basically have to stock implants. That's it. You just stock implants and some screws to attach your teeth. The rest is done in the lab, 3D CAD design and 3D printing and milling. There's not much you need. So your overhead is way less, your parts for lab are way less, and this leads to a better result. It leads to a more accurate, a more streamlined approach with more profit and more patient satisfaction and less overhead. And you can see down here, I highlighted this, you know, you can push your cost down to below $800 an arch. I mean, that's amazing. That's including implants. You don't need abutments. You basically need 4 implants, 4 anchor screws, and a printed restoration, and then transition to a milled zirconia restoration. I mean, you add all those costs up. If you're doing that in-house, you're at around $800 to $1,000 per arch. Now you can be competitive in this very, very competitive market for dental implants because your overhead is now 25% of what it used to be. So the news story is pretty exciting. We've got these wonderful pieces of technology. We've got our intraoral scanners, which we use here in my clinic every single day. Photogrammetry is a wonderful tool for getting accuracy. 3D facial scanners, great for diagnosis and treatment planning. We have CAD software to help us design these cases digitally. We have wonderful implant systems like TRI that can eliminate abutments and provide a custom, you know, product in the same day. We can 3D print these restorations while the patients wait, which is amazing. And then when patients are ready for more definitive prosthetics, we can precision mill these in a 5-axis mill and get a direct to implant connection. and we can test. We can look at our results and plan all of our cases out on digital CBCTs. So what could be better? What's missing? Not much. This is super exciting. I was one of the first guys in the world probably to use the ICAM system, photogrammetry on a TRI implant. This is one of my buddies, Luke. He was a hockey player, got his front teeth knocked out when he was playing hockey. He had a bridge. We'll go through his case in more depth, but he had a bridge that went across his anterior teeth. He was on vacation in the Bahamas, and his bridge fell out on the plate, and he had to super glue it back in until he came in to see me. And so we replaced his anterior bridge with an FP1 prosthetic that turned out very well, and we were able to use the photogrammetry system to give my lab that precision accuracy that we needed. So this is what we do at Full Arch Masters. We do cases like Luke's. We teach you guys how to do all of this. The curriculum is kind of broken down into 3 courses. The main course that you're going to want to be interested in is our flagship course. This is the soup to nuts, A to Z workflow course that involves surgical training, laboratory training, treatment coordinator training, 3D printing, all the above, troubleshooting and complications, aesthetics and finishing. We jam pack as much as we can into 4 days. Our next course is in November, and then I think we have one in January as well. So you get to come and do this hands-on. You get to treat patients while you're here. You get to do the scanning. You get to see the laboratory, do the 3D printing, work with the implant systems. So it's all done in one place. Our laboratory course is much more intensive on the laboratory side. It's also a 4-day course that focuses on CAD designing for full arch cases. You can design your own cases, 3D print and mill your own cases. And then the second half of the course is spent on aesthetics, learning how to contour zirconia and printed bridges and how to make them look beautiful and ready for the mouth. Our surgical course, we just got back from Cincinnati this weekend. We had an amazing surgical course in Cold Spring, Kentucky over the weekend. This is a 4-day live patient experience where you get to go in and do full arch cases. So we teach you how to do advanced surgical techniques or basic, depending on your skill level. You get a mentor that's working with you on each case, and you get the treatment plan, and then have the patient be sedated, remove any teeth, remove any bone, place the dental implants, and restore that case all in a single visit. You get to do a couple of arches by yourself, but obviously you're having your hand held by a surgical mentor who's standing right over your shoulder, helping you should you run into any problems. People can combine these 3 courses into what's called our fellowship. So many doctors have done this. We've had, I don't know, 20 or 30 or 40 docs go through this over the last couple of years. You get to combine all 3 courses. So you combine the flagship course, the lab course, and the surgery course. And then we do webinars just like this, educational webinars on specific topics every month. We've done about, I don't know, 25 or 26 of them already in the library. So you get access to this huge catalog of business development webinars and lab development webinars, troubleshooting, complications, marketing, branding, patient financing, you name it, we've covered it. In total, it's about 100 hours of continuing education credits, and it's spread out over about a year. Okay, let's talk about a few cases. This is the case that Amir was talking about. This is actually my father-in-law. I've done a full mouth reconstruction on him already, and I've replaced multiple teeth as they break because he's a tooth destroyer. So he's broken zirconia crowns, he's broken bridges, and he called me and said, "Oh no, Ryan, I broke my front tooth." And I said, "Well, send me a photo," and this is what it looked like. And I knew right away I was in trouble. This is already a root canal tooth. So I decided to have him come up, and I was going to remove part of the tooth. I removed the palatal half, and I left a socket shield on the outside of the tooth to protect the bone. And then I placed a TRI implant right behind it. So I did the partial extraction therapy first, removed most of the root, and I left the socket shield, which is like a thin shield of tooth remnants on the facial extraction socket. Then I drilled behind that and went apically. So here's me placing the TRI dental implant. I think this was actually the first TRI dental implant I ever placed. So a lot of faith already jumping into treating my father-in-law. So here's what we did clockwise from the top left corner. I inserted the implant and I got really high insertion torque. It was probably more than 80 Newton centimeters. The second photo here, you can see the implant, the TRI implant, living right behind my socket shield. This is kind of a minimally invasive surgery, so I have what's called a mini flap. I only raised one papilla, and I kind of pushed back the extraction area just very gently. From there, I put the scan body on. You can see on the bottom left here, that's their scan body. It's engaging, right? This is a single unit crown, so it kind of slots in. There's like a slot in the implant that gives you your timing. Once the impression coping scan body was in place, I scanned it with the Trio scanner. You can see me doing that here. And then I left a healing abutment on the implant for a few minutes just so we wouldn't get tissue collapse or bone graft or anything inside the implant. So I left my father-in-law just like this for a few minutes while we went to the lab. And we designed a single unit crown that had an angled screw channel. This screw channel would have come through right at the incisal edge of the facial if we didn't angle it. So I'm certainly glad that we did. So I was able to screw this right into the mouth. You can see there's no tie base, there's no abutment, there's no pickup in the mouth. This is all done digitally. And I was able to exactly copy his previous crown. We put that in the mouth and super glued it real quick, and then we did a pre-op scan. So I knew exactly how this tooth looked. And we copied that design into the 3D printable crown with the angled screw channel. This was then inserted into the mouth and torqued to 35 Newton centimeters. And then that access hole was covered with some temporary filling material. He came back about 4 months later, and I took the temporary off. Everything looked beautiful. I didn't need to make another impression because the first one was perfect. It was complete biomimetic dentistry. I copied the exact crown that he had. We had the shade already because I kept his crown. And all I did was unscrew the printed one. Oops, remind me tomorrow. I unscrewed the printed crown and I screwed on the final crown. I never had to take a new impression. I didn't have to get a shade. I just confirmed the healing, which you can see the healing here is beautiful. I confirmed the integration on X-ray and with a torque test. And then I just torqued in the new crown, and this is the final result. You can see the TRI implant is on site number 8 or on the left side here, and it's sitting next to a neodent. They both look wonderful. I think the TRI probably looks a little nicer than the neodent one, but they both look great. And you can see there's a little bit of a socket shield there. There's a little bit of tooth left over. You can see the TRI implant goes way apical to the extraction socket, so that's where I got my my primary stability. And then we sealed over this crown with some composite so that the access hole is covered, and you can see the result is nearly flawless. Let's expand this a little bit and talk about a bigger case. This is a standard all-on-4 tilted implant case, like an FP3 gingiva and tooth case. She had some failing teeth. I removed those. You can see on the top left, her pre-op x-ray has a bunch of decay. The teeth needed to go. So the teeth were removed, the ridge was reduced, and then I placed 4 TRI dental implants in the kind of the standard positions, the second bicuspids and the lateral incisors. Those are my favorite sites. I placed these healing collars on so that I could suture around these, and I on the top right, you can see my suturing there. Once I had everything sutured up, I unscrewed those healing caps and I put the scan bodies on, and this is me putting the scan bridge together. These are little printable bridges that go from scan body to scan body. These are kind of luted together with some composite, and it just provides a track for the intraoral scanner to get from one scan body to the other. Once this is scanned, we send this to the designer, and the designer designs the screw retain immediate load prosthetic. And again, you can see, if I go back here, you can see the implants are at pretty severe angles from each other, probably about 50 degrees off axis, and the access holes are most likely to come through the incisal edge or the buccal. And you can see with angled screw channels, we're able to just put those screw holes in the ideal position and not have anything come through the facial. So install the same day printed provisional. There's no multi-unit abutments. There's nothing holding this together. It's just a print that goes straight into the mouth. And these screws can be torqued down. Then you have a very, very rigid fixation for your implants. I think she's gonna, oh, you can, I think you guys can hear that, right? So here's the printed provisional in place. She's gonna bite down. Occlusion is great. This is her right after surgery. We're here with Denise. You have not seen your new teeth yet, have you?
No.
Okay, so we're gonna give you a mirror and I want you to give yourself a big, fantastic smile.
Okay.
You ready? Well, first, hold on. We get a sneak preview. Give us a big smile. Snazzy.
The pearly whites.
They are pearly. Okay, you ready? Let's give her the mirror and take a look. Ready?
Oh. Dang. Wow.
Pretty amazing, huh?
Oh, I can't do it.
Look how natural they look.
Yes.
Big change, huh?
Huge.
And all in one day. Wouldn't you believe it?
Wow.
So you have an implant brand that's relatively new to the United States. It's called TRI Dental Implants. It's matrix implants, and you're probably one of the first people in the whole country to have access to this technology.
Wow.
So, you know, maybe you can say, I love my matrix implants.
I love my matrix implants.
And I'm gonna take your videos and your pictures and I'm gonna present at the national sales meeting for them in about 2 weeks. So you're gonna be
Okay.
fully famous.
Okay. You did awesome.
Oh, so did you. Thank
You and your team. Thank you.
So another happy patient. We love when they're happy. Okay, this is the third case I'm going to talk about. This is again my buddy Luke. He's a good friend of mine, and this is his situation. You can see on the bottom left here, he's had a ton of dental work. He's had a complete reconstruction already, and I've been working on him for a couple of years. And he calls me from the Bahamas and says, I've lost my front bridge. What do? I said, well, glue that sucker in and get back on an airplane, and we'll fix you up when you get here. So he comes in and the bridge is just wobbling. I take the bridge off with my fingers, and this is what's left underneath. You can see on the top left, there's not much left to work with. So in the middle left, I've raised a flap. I've taken the rest of the teeth out. I've curetted the sockets. I've reduced the ridge where needed, and I'm ready to place some implants. So on the bottom left, you can see the 4 matrix implants and osteotomies in place. Then you can see on the bottom right, I've got 4 implants in place. These are all going to be splinted. I suture around them to give a nice keratinized tissue on the buccal where I can and get a nice emergence profile. I then unscrew those healing abutments that I used for suturing, and I put the scan bodies on. We didn't even need to connect these because they were so close together. We just went ahead and scanned them. This is what we got out. This was his immediate load prosthetic, and again, you can see the implants are very flared. You can see from the drills and from the impression of the scan bodies that these are going to be very facial because of where the bone is. But you can see where the access holes are ideal, and that's because we use the angled screw channel solution. So this gets screwed into the mouth. We take some radiographs and we see that, you know, I put the implants where the best bone was, which is great for them. But I didn't have to put my implants in a compromised position to get the screw access hole in a favorable exit point. So this is really, really nice. You can put your implants where the best bone is, and then you can angulate your screw access channel to be ideal. This is what it looked like after it healed. He came back, and by then we had photogrammetry. So I said, hey, let's redo our records now that he's healed up, and let's do our ICAM workflow. So we put the digital healing caps on the ICAM bodies. We scanned that, and then we scanned the implant positions using these dominoes, and we're able to mill him a final restoration. That's me and Luter and Barry Matthews, good buddies at the Sprint Ray event, actually, Amir, last year at the Metallica concert. So we had a good time. That's all I really wanted to talk about. I have had good experience with TRI so far. Again, I'm really excited for what you guys will do in the future because you're a very innovative and forward-thinking implant company.
Thank you so much, Dr. Dunlop. That was wonderful. We do have one question. I'm not sure if it was answered, but it said, can you technically mill the final at the time of placement and place that and totally avoid the second appointment?
You absolutely could. If you scanned at the time of placement, you could, if you could get a design quickly, and then if you could mill quickly enough. Now, remember, you're milling direct to an implant connection, so you need to mill in something strong enough to withstand the forces. So you got to mill in zirconia or plastic, right? So if you're going to mill in PMMA, that's maybe you can consider that a final restoration. I'm not sure I would. So you're going to probably mill in zirconia, and zirconia can be milled very quickly. Let's say it's a crown, but then you've got the sintering. So you've got to take it out of the mill and clean it up, and then you got to put it in the sintering oven for anywhere from 10 to 12 hours, depending on your system. So doing that in a same day would be impossible. But you could print a restoration and install that and send the patient home, and then you could just turn around and mill that as a final restoration for the patient to deliver at the post-op. So you could do it that way. But unless you're going to do an overnight delivery, you could mill a crown and then sinter it and be done with it. You could mill a pre-sintered crown, that would just take a longer milling time, or you could mill something like Emax, but I don't think Emax is probably strong enough to withstand the forces against the implant, so I probably wouldn't do that. So yes, you can. You would be just limited by your sintering protocol and your finishing protocol, but you absolutely could do that. Amir, any other thoughts on that?
No, absolutely. You just nailed it. It definitely can be milled, but the timing is a question here.
Right, right.
Right, thank you. Next question. How do we deal with stripped screw heads?
Good question.
So I don't know if you have ever even seen anything stripped with the TRI, Dr. Dunlop, but we have a lot of studies and a lot of reviews that we have never had any stripped screw head so far, whether it is a star shape for your angulated screw channel or the hex for your straight screw channels. And the reason being so is because the screws are so bold, the material on the top, on the head of it is much more than, any other screws that you see in the market. You may see a lot of stripping with the other screws, and that's because they're so teeny tiny. So basically spokes on the screw head are so miniature that they can get stripped easily, but not on matrix.
Yeah, I haven't had any issues yet with any screw stripping because of what Amir said. The screws are so large, and they were smart. They made kind of a deep hex connection for the screw to grab. So I haven't had any issues with that yet. But again, I've only been placing them for 6 months or so. So, it's hard to say what that's going to be long term, but my gut instinct says that it's not going to be as much of an issue as screw stripping was with the tiny Nobel screws or some of the Straumann screws that had a very shallow, delicate screw connection. This is a deep 2.9 millimeter bolt screw that really engages your screwdriver very, very well. I will say that the angled screwdriver is a ball driver, so that's not going to engage quite as deep, and you can have a little skipping. But again, it's so early in the process, I can't say whether or not that's going to be a huge issue. My gut feeling is no. Yeah.
Thank you. Next question. Any issues with path of insertion with full arch?
Yeah, that's a great question. The simple answer is yes, there can be. So if you think back to my case, I had 2 tilted implants in the back and 2 straight implants in the front, and the angle of divergence between those two is probably 50 degrees, 40 degrees. What you create is you create a path of insertion problem if you were going deep into the implant. So if you're going fixture level with a traditional bone level implant, you would never have a path of draw for that prosthetic. What TRI has done is they've raised the connection up to the tissue level more or less and made it very flat. So it's doesn't have a path of insertion physically for your prosthetic. However, the screws still have to go through your prosthetic and into the implant. So it's easy to put the screws in because you hold the prosthetic and you put one screw in at a time, and each one goes separately. Where you run into a path of insertion problem is when you're trying to remove that arch, because now all 4 screws are engaging at different angles. So even if you loosen them, when you try to pull down to get the arch to come down, it doesn't go because the screws are still partially engaged. So the solution to that is a separate driver that actually pops into the head of the screw and pulls it out. So you unscrew it with the bolt with a ball driver, and then you have to take this separate driver and insert it into this screw, and it snaps in, and then it pulls the screw the rest of the way out, and the bridge just falls. So the answer to your question is yes, there are path of insertion problems, but there's no way around it. You have to have this second driver that will actually disengage the screws. And at the beginning, I was annoyed. I was like, come on, guys, this is so dumb. But I don't need MUAs, and I have a 2.9 millimeter bolt screw, and temporaries are stronger. So you give and you get in life. And so what you give is you give up the ease of these bridges coming in and off. It is an extra driver, but what you get is so much more in return.
Yeah, absolutely. Thanks, Dr. Dunlop. If I want to add just a note here to what just Dr. Dunlop explained, definitely when you have different implants at different angles, and even though you unscrew the screws, still because, you know, the screws are inside and kind of engaged, not tightened, but I mean, not into the threads, but still being placed there, it's going to prevent it from coming out altogether. So you want to make sure that you remove the screws before you're getting it out. But maybe another thing that I wanted to touch on here is sometimes if you have it at that angle, and because you're reaching to passing through the tissue and reaching to the platform, implant platform. Now that implant platform could be anywhere in the middle of the tissue or very close to your bone, then that kind of angled neck or the chimney leg that comes out of your full arch could also impact your path of insertion. So that is the part that we see in the design part. You know, when somebody is designing for you, it needs to get certified. Obviously, certification is easy and it's free online. They get certified on how to design. Those undercuts and all of those are going to be basically taken care of within the design, so that you have the very straight path of insertion. When there is no screw, it just goes in and comes out without any problems.
Right. So the design team that you're working with has to understand the evolution here and what's changing, because if you adopt all of the same principles that you would use on a screw retained full arch case from, you know, Neodent or Nobel, and you try to apply those same principles to TRI, you're going to run into some problems. They have to understand the difference in technology and philosophy. So that's why TRI is smart to try to control the design process for their implant and offering these amazing design services and milling services, because it's a new dogma. It's not the old guard. This is kind of a new methodology, and it does take some lab education and clinical education to do things slightly differently with this implant.
Yeah. Yeah, but in case you have your own lab, like how Dr. Dunlop has the full lab there, you know, designing, milling, everything, we do help you to, you know, get educated and certified so that you can start milling for yourself in-house. I mean, designing and milling, everything.
Right.
Okay, well, that was the final question. I want to thank everybody again for participating and attending the webinar, and a special thank you to Dr. Ryan Dunlop for being our guest speaker. We really appreciate your time, Dr. Dunlop.
My pleasure.
All right, well, thanks again, and I hope you have a wonderful night.
Thank you. Have a good night.
Thank you, everyone. Have a good night.
Bye-bye.
Bye-bye.